Welcome to Reliability Matters, a podcast for the electronic assembly industry. Each episode covers topics related to reliability, best practices, and environmentally responsible assembly techniques, with insights from experts across the electronic assembly industry. Now, here's your host, Mike Conrad.
Welcome to another episode of the Reliability Matters podcast. For those of you who are counting, this is episode number 130. Let's go back a few episodes. Some of you may recall episode 121, where I spoke with Dr. John Mitchell, President and CEO of IPC, about his new book, Fire Your Hiring Habits. During that episode, we talked about best practices for hiring the best people. I'd like to travel a little bit up the river to talk about where potential candidates come from. While many of the people we interview for positions within our companies come from other companies, more and more, we are seeing new people enter our industry. We've talked a lot about the silver tsunami affecting our industry. The fact is, baby boomers are entering retirement in greater numbers. Check out this recent news report.
A lot of the advice that we give to boomers, we would give to anybody, but the baby boomers are a different generation in part because it's just so big. There's so many people that were born. Like you said, Heather, 10,000 baby boomers are retiring every day, and that trend will continue.
From now until 2030, 10,000 baby boomers every day will hit retirement age. Millions will begin to officially retire. This is creating a terrific opportunity for young people to enter our industry. Several years ago, I was doing my annual speaking gig at the SMTA Pacific Strategic Electronics Symposium in Hawaii. I had the opportunity to share my breakfast table with a longtime colleague, Dr. Lasky, a professor at Dartmouth College. Over the course of breakfast, he asked me how I got into this industry and, more specifically, how I started my company. Dr. Lasky is an engineering professor at Dartmouth's Thayer School of Engineering. He also teaches entrepreneurship to his soon-to-be engineers. Dr. Lasky invited me to come to Dartmouth and speak to his students. I was, of course, more than happy to take him up on his offer, and I have spoken to his students on the subject of entrepreneurship every year for the past several years. I've been quite impressed by the emphasis on entrepreneurship within the Thayer School of Engineering. We live in a time of marvelous evolution within the electronic space. So many new and innovative electronic products are being introduced, fueled by IoT, Internet of Things, the electrification of automobiles, advances in communication, and so much more. Education is the bedrock of our industry. It is the foundation for which much of our industry and the products we make are built upon. I've had Dr. Lasky on my show several times, and I thought it might be a good idea to invite his boss, the Dean of Dartmouth's Thayer School of Engineering, onto the program. Dr. Alexis Abramson is the 13th Dean of the Thayer School of Engineering at Dartmouth. Prior to joining Dartmouth, she was the Milton and Tamar Maltz Professor of Energy Innovation at Case Western Reserve University and served as a director of the university's Great Lakes Energy Institute, focused on creating sustainable energy technology solutions. During the Obama administration, Dr. Abramson served as chief scientist and manager of the Emerging Technologies Division at the U.S. Department of Energy's Building Technologies Program. In 2018, she served as a technical advisor for Breakthrough Energy Ventures, a $1 billion effort launched by Bill Gates to combat human-driven climate change. Dr. Abramson's research has focused on novel techniques for thermal characterization and nanostructures, the design and synthesis of unique nanomaterials for use in alternative energy applications, virtual energy audits for building energy efficiency, and strategies to accelerate technology commercialization at universities and research institutions. Dr. Abramson earned a bachelor's degree and master's degree in mechanical engineering at Tufts University and a PhD in mechanical engineering at the University of California, Berkeley. It is my distinct pleasure and honor to welcome Dr. Alexis Abramson to the show. I do have to take myself off mute. I was just so enthralled and just captivated by that, by your bio. I even though I recorded it, it was still very, very interesting. Yeah. Welcome to Reliability Matters. Thank you so much for being my guest today. I really appreciate you being here. And I have been to your campus many times. It's absolutely beautiful. I'm a West Coast boy, right? So I was born and raised in California. So anything more than about 35 years old is considered an antique. You know, it's old. So
Well, we are
walking.
very antique here. Yes.
Yes, and I've never seen so much brick, in my life. That's one thing
Right.
I just really admire about East Coast architecture, particularly in the university settings. It's just
Sure.
beautiful.
Absolutely. Lots of energy efficiency and buildings issues to deal with here on this part of the world. But yes, beautiful nonetheless.
Nonetheless, it is beautiful. And I do have to figure out a different time to come. I always come and speak to your students, usually in, I want to say January or February, somewhere around there. And this California boy really gets cold. I just a little anecdote before we dive in. I was there, this a couple years ago, and I was speaking to Dr. Ron Lasky's class, and it went a little long. I gave my talk, and then there was a Q&A, and the Q&A wouldn't end. And then Ron said, okay, I got to go. I have to catch a train or a car. I have to get my, whatever it was. I got to go. Thanks for coming, whatever. So I finished up what I was doing, and then I realized that the only jacket I own was in Ron's office, locked up because he had gone. So I had to walk to the hotel. I was staying at the Hanover Inn, so you're familiar with that. It's not that long a walk. It's half a mile or so, but I think it was in the single digits, and I was just in a shirt like this, right? So yeah, that was fun. But my best experience was we were so out of time. I said, look, students, I'm staying across the street at the Hanover Inn. There's a bar downstairs. I'm going to hang in there. If anyone has any more questions, feel free to meet me in the bar, right? And so I went over and I ordered a drink, and of course no one came. What was I thinking, right? I'm this old guy. Here's these young students. They probably have a million better things to do when they're done with class. So I ordered a second drink, and of course no one came. And finally I said, okay, I'll just have one more. And I'm staying at the hotel, so I just have to go up the elevator, right? So I'll have one more drink. So I had one more drink, and of course no one came. And I was still high on my experience of talking to all these young people. So I was still feeling good. I didn't feel bad they didn't show up. I kind of expected they wouldn't. So I cashed out. I got up from the table. I'm headed out of the door into the lobby, and here come an entire group of your students, of Ron's students.
Right.
And they said, oh, Mr. Conrad, sorry we were late. We all had to do X, Y, Z, but, we want to talk more. I'll tell you, it warmed my heart. This old man, this old guy with a bunch of foxhole stories and these. Now, I don't think it had much to do with the fact that I was going to offer to buy them drinks, or maybe they just really wanted to talk.
I'm sure not. No. The curiosity alone, I'm sure.
Absolutely. So. It was all intellectual. Yes. But then I had to I'm already 3 in, and like, oh well, took one for the team. But it was great.
Thank you for doing that.
Yeah, just when I think, just when I get kind of soured on society, and I think, oh, the next generation, we're doomed with the next generation, just like our parents thought and their parents thought. I spend a day talking to real students in a real university setting, and I'm just pumped up. It lasts me another year, and then just about the time I start getting cynical again, Ron invites me back, and it pumps me up for the year. I have a lot of enthusiasm. Alexis, what inspired you to pursue a career in academia and eventually make your way to dean?
Sure. Well, I would say it started with an interest in engineering. I was very good at math and science when I was younger. And you kind of marry that with a real drive for curiosity, right? I was always interested in how things worked and why they worked the way they did and how we could make them work differently. But interestingly, I also came from a family of non-engineers in large part. And so I joked with my parents pretty much from age 3 on, somebody had to figure out how to fix things around the house. And so that became me. I started sort of taking over, fixing things and understanding how things worked in the house. And so really then just fed that curiosity, that interest in engineering. And then after I graduated with a bachelor's degree from Tufts in mechanical engineering, I became a quote unquote real engineer. I worked on the Big Dig project in Boston. That's where they put miles of freeway essentially underground, and was fascinated by that, but still felt that I loved to learn so much. I started to question whether or not that was the right sort of lifelong job for me, and how close to lifelong learning could I get? What job? And academia is the obvious answer to that, right? Being a professor is a great way to just constantly be learning and then helping the next generation learn as well. So there was a match there. And then as things do in life, one thing leads to another. I really enjoy thinking strategically and thinking how to innovate and working with people, and kind of led to me pursuing different leadership roles and ultimately taking the role here at Dartmouth as Dean of Engineering.
Yeah, excellent. You and I share one common trait, and that is our curiosity. I was also, as a young child, I was also extremely interested in how things worked. And I used to get in quite a bit of trouble because I would get home from school before my parents would get home from work. So I would start taking things apart. I would take apart televisions, toasters, blenders, clock radios, etc., just to figure out how they worked. That did not get me in trouble. What got me in trouble was I had less of an interest in putting everything back together. And so my parents would come home and all of their appliances, or many of their appliances, would be in various states of disassembly. And but that, I love the quote by Steve Jobs, which I think it was at a commencement address at Stanford, I believe. And I think his two words were "stay curious." Right. I think that was properly attributed to him.
Absolutely.
And I think as long as there are things we don't understand and a desire to understand them, people will either through formal or informal means become educated.
Sure.
My dad,
absolutely,
God rest his soul, my dad would never be accused of being a good motivational speaker, because one of the things he instilled in me and my sister over the years was, son, you live your whole life, you learn your whole life, and you still die stupid. And I'm like, thanks, Dad? Is that? Yeah, I get the point. I get the greater point. Right. It's like we can't learn enough. Tell me about the ethos of the Thayer School of Engineering at Dartmouth.
Sure.
And how, if it does differ from other schools, how does it differ from other schools?
Sure. We are quite a different kind of school of engineering. When I talk to prospective undergraduate students, so high schoolers, I always say this is going to be the weirdest information session about you're going to get from a school of engineering. So, and I mean that in a good way. So one thing, we are engineering integrated with the liberal arts. So there are some universities where you apply to an engineering school, you get in, and largely what you're doing is engineering related courses or STEM related courses. Here, we believe really strongly in integrating with the liberal arts. So we encourage our students to take philosophy and anthropology and English and studio art, and to take the learnings from those courses and figure out how to integrate those learnings into engineering. Oftentimes we separate those different disciplines, and we're really all about bringing those together. So we offer a BA, a Bachelor of Arts in Engineering, right, is one of the degrees you can get at Dartmouth because of that integration. You can also get an accredited Bachelor of Engineering degree, which is more like what you would get at other institutions. But isn't it nice to be able to have that flexibility in our undergraduate program to pursue engineering in this very different way?
I like that. That's just depth and breadth, right? I mean, sometimes, particularly in the sciences, there's a lot of depth, but not a lot of breadth. And sometimes that reflects later in life in one's personality and one's, social skills and all of that.
Sure. Absolutely.
But I love the idea of providing a liberal arts view on a science education, because where does science go? Science goes to serve humanity. Humanity is much wider than the science itself, right?
Yeah. So you're speaking our language. We call what we do human-centered engineering. And that really means two things. One, that we're really thinking about the impact on society in the classrooms and the education we deliver and the research that we do. And then we're also thinking about the humans in the classroom, right? How do we meet everybody's educational needs? People come from diverse backgrounds. And so bringing those pieces together is really a unique kind of approach to educating engineers today.
Yeah, excellent. Historically, engineering has been a male-dominated profession. So many things. I mean, go back long enough, everything was a male-dominated profession.
Yeah.
But for some reason, engineering has kind of clung on to that. That ideal. Ideal is the wrong word, but that concept. Is that changing today?
I hope so. And, when I started in 1990 or so as an undergrad, there were about 10%, a little bit more in some disciplines, certainly, of engineers in the workforce were women. So it was about 10%. Now we're closer to 15, 20, between 15 and 20%, a little bit higher in some disciplines. So the largest representation of women in engineering are in disciplines like environmental engineering and biomedical engineering. And the lower proportions are in more conventional disciplines like mechanical engineering and electrical engineering. And so we ask ourselves, well, why is that? And there are a whole slew of reasons, why that is, and why haven't we grown even more than we have today? Why is it still at 20%? Bringing that human piece I was speaking about, right, that human-centeredness, the societal impact, has been shown in research to be one way to attract more women, more people from diverse backgrounds to engineering, right? Because they see that connection to the impact that they can have if they actually go into this field. And so that is a reason why it has been increasing. And I think also a reason why it hasn't increased as much as it should be increasing. Here at Dartmouth, in the class of 2023, as an undergrad population, we graduated 53% of the graduating engineering majors were women. So we're at gender parity, and some years above 50% of our graduating class. And so we really celebrate that. And we really point to that idea of having that human-centered focus, a more focus on inclusion and belonging, is one way to help people who think they might be interested in engineering but kind of doubt their abilities or doubt that does that link with their passion, helps make those connections, make the degree more accessible, and therefore help them go into those kinds of career and professions.
Yeah, that's terrific. I speak at a lot of conferences, symposiums, and I've been doing it since the late 80s. And, for all really up until the last decade, I'd say, it wouldn't surprise me if a conference was entirely old guys, seasoned veterans, right?
Right.
And
right.
The generals and the admirals of the speaking world. And it would be a rarity if a young person let's say under 30 spoke at one of these events, and it would be even rarer still if a young female or a female of any age spoke. I can remember conferences where there wasn't one single woman either in attendance or certainly at the lectern. That's changed, and I'm seeing both young people and I'm seeing a mixture of men and women speak at these events. It's still lopsided. Maybe not in the education world because it's we haven't received all those people yet into our industry, and they haven't been in long enough to be able to stand at the lectern and share their knowledge. But I can see that over the horizon. I can see what schools like yours are doing will eventually land in our industry. They will make it to, some of them will make it to our industry, and some of them will make it to our lecterns, and we will hear from them. And then that will just get the snowball rolling even faster because more people will see them as role models and say, I want to do that.
I want to do that. And it's important to note too, so many studies have shown, and we've had our own direct experience, that having diverse teams just leads to better solutions, right? And so by having more of that diversity, right? If you're an engineering company trying to solve an engineering problem, you have more bright minds from different perspectives at the table, you're going to end up with a better solution. I could name a lot of solutions that are out there, consumer products that are out there, for example, that were horribly designed, right? And you question, did they really have diverse perspectives at the table when they came up with that solution? So,
Right.
It's important.
Well, Maslow said, if all you have is a hammer, you see the world as a bed of nails, right? And I think that same philosophy can be applied to our social experience, to our economic experience, to our life experience. If we have the same gender, the same subset of people coming into engineering, we're going to get the same mind think, and we're going to produce the same types of products. It's just like. Well, I hate to say that. I don't want to be accused of just being an Apple fanatic, although I am. But by saying Steve Jobs' names twice in this episode, but he brought a very artsy view to computers. His love of calligraphy ended up changing the way every computer displayed text right from then on. I mean, that tiny little love of calligraphy, which would otherwise be deemed as that's a random thing to learn. What were you short a few credits? That's the kind of thing.
Right.
Ended up changing the world of computing because up to that point we had fixed fonts and fixed space fonts,
right?
And then
absolutely,
and it kind of changed the world in that respect, in that tiny little respect. But it changed what I'm looking at right now. I'm looking at fancy fonts on a screen right now, and that would not have been possible, were it not for one crazy guy, with this kind of liberal arts, specialty in calligraphy, and bringing that into the engineering world. What efforts, just to finish up this subject on male-female inclusion and concentrations in our industry, what efforts are being made either by the universities or perhaps the high schools to attract more women into STEM?
Yeah, so I think making engineering more accessible to people from different backgrounds. So let's say you're really bright, you love math and science, but your high school didn't have calculus, right? It's up to universities then to provide you with a path that allows you to still major in engineering, even if you're taking your first calculus class, your first semester freshman year. And not a lot of schools accommodate for that. And I think that is a deterrence to more and more students. So it's something that we are working on in higher education to make engineering and STEM more accessible. The other piece I would point to is having more hands-on, project-based, sort of real-world experiences is absolutely critical, right? Making that link between the differential equations you're solving and how that relates to crack propagation, and how that relates to climate change, right? Making that linkage is something that we haven't done very well or very extensively in higher education. And that linkage to that real world, why am I learning this, is a question that this generation is asking even more than previous generations. And so we need to really adjust our teaching so that we can really attract more students into STEM, and particularly more students from those different backgrounds, who come with different assumptions about their abilities, so that they feel included and that they can learn in the environments we provide.
Yeah, very good. You made a comment several months ago on a video that I watched where you stated, we don't do engineering in silos. Explain more about that. What did you mean by that?
So at Thayer School of Engineering, we don't have engineering departments, and that is on purpose. We have a School of Engineering. We do have some program areas like biomedical engineering, electrical engineering, where our faculty and students can kind of gather in those disciplines, but we're not set up like a traditional School of Engineering with sort of siloed departments. So that's a practical answer to your question. I think really, though, we do this on purpose because it really better catalyze interdisciplinarity. the problems that we're facing in society today are not simple problems anymore, right? We're not designed trying to figure out how to make a wheel, right? As cave people did eons ago, right? These are very complex problems. They're very multidisciplinary problems around healthcare and AI, right? Around climate mitigation and batteries and solar and data analytics, right? So these are very multidisciplinary problems, and they require people who are trained in thinking across disciplines. And so by not having departments set up traditionally, it really enables much more of that rich collaboration and connection that you sometimes don't get at other places. And then also, right, my grandfather had essentially one job at one company for his entire career, right? That doesn't happen anymore. Our students, their first job, they're in it for 3 years at best, and then they take another job and then another job. And so having a more systems-based approach, a really broad-based approach to learning in your degree program, be it an undergraduate or graduate degree program, is really important because people are changing jobs all the time and they need to kind of draw on a skill set they might have forgotten, but it's okay. They can go back in. It's much easier to relearn something once you've learned it in school than to start from scratch.
Yeah, very good point. You touched on this a little earlier in a prior answer, but as you can see, the title of this episode is Human-Centered Approaches to Innovation. And you've spoken in the past about human-centered approaches to engineering, which of course leads to innovation. Tell me more about that philosophy. What is exactly meant by human-centered approaches versus maybe a conventional approach?
Sure. Yeah, the more conventional approach is really about taking the perspective from more the skill or the technique or the math. So when you're in, let's say, a heat transfer class as an undergraduate mechanical engineering student, you're learning a lot of equations and you learn, okay, well, if it's in a solid, you use this equation. If it's a fluid, you use this equation. So very sort of practical approach to engineering. And I think that has served us well over time. And I think some students are fine learning in that more, call it cookbook approach. But more and more that curiosity really is woven into how students want to learn and how students need to learn to tackle those very complex societal problems. And so this human-centered approach really is about making sure that societal impact. Why am I learning about heat transfer in the first place? How does heat transfer impact climate change? How can I use it to design new materials to better insulate homes, right? That practical real world is being brought into the classroom. And then it touches on the research piece, right? We do have a really strong research program here at Dartmouth, as do many other universities. And so sometimes you're doing fundamental research and sometimes you're doing research that is close to that societal impact. And we really, while we have engineering faculty of all kinds and students working on all kinds of research, we really do emphasize that closeness to the societal impact. And that comes with more of an emphasis on translation and entrepreneurship that we have too.
You and I are on the same mind link right now because my next question was going to be research and innovation are often key components of a university's identity. How does the Thayer School of Engineering at Dartmouth support and promote research activities among both faculty and students?
Sure. So like most research active universities, our professors write grant proposals often to the federal government or to industry. And as a result, we have funding to then support the research enterprise, right? The supplies that they need, we pay stipends to students to work on various research. So that is sort of practically kind of how that works. We really continue to support our research program by making sure that the students who are experiencing it, for example, the doctoral students, are really paired with a faculty member and with a project that is meaningful to them. sometimes I call it the choose your own adventure approach to our doctoral program, so that students can really explore their interests that they have, so that they get really excited about the work that they're doing and then translate that into society. So we kind of take that sort of unique approach to the PhD, the research program. Also, just about 70% of our students at Dartmouth that are undergrads have a research experience, and that's a pretty high number. We really like our students, those who are interested in STEM, to get involved in research, to have that real world experience. And again, many of those students, they catch the bug, and they may not become researchers in their careers, but they sort of catch that bug and want to know, want to learn more, and want to think, how do I take this, whatever it is they're doing, even in their careers much later on, how do I take this and really move it towards impact?
Yeah, excellent. One subject that's quite near and dear to me is entrepreneurship. You know, I started a company out of my garage 32 years ago, and had that journey. And while most people use the word entrepreneur in the context of someone starting their own business, as I did, I think that the term entrepreneurial can be applied not just to company founders, but to people working in cubicles and people working on a factory line.
Yes.
I think entrepreneurship is a mindset that is often manifested in starting a business, but not exclusively. And one of the things that I've always been impressed with Dr. Ron and Dr. Eric Fossum, I think, who ran the program before Dr. Ron. By the way, Dr. Eric Fossum was on my show quite a while ago. And for those of my audience who don't remember, look that episode up. Dr. Eric Fossum, who's a professor at Dartmouth, is also the inventor of something you have in your pocket right now, and that is the modern digital camera, and more specifically, to get geeky, the CMOS image sensor.
Exactly.
He looked at something that was already out there, and he said, I can make this better. And he did. And he's the only person I've ever had on my show, and I'm guessing the only professor at Dartmouth that has won an Emmy.
That is correct.
Right? That is not a typical university accolade, unless it's like the Hollywood Film School or something, right?
That's certainly from an engineering professor.
Probably the only engineering professor in the world ever to win an Emmy, right?
We'll have to look into that a little more.
Yeah. That's a reason to go to Dartmouth, right?
Exactly.
One of many. Anyway, we're talking about entrepreneurship. What is your view on entrepreneurship? I know you do have a view on entrepreneurship, and how is the concept of entrepreneurship weaved into education?
Sure. Yes. I'm a big supporter of getting those wonderful ideas and that research that we're doing out into society to have the impact that it needs to have as quickly as possible. And certainly entrepreneurs do that. But you mentioned, Mike, also, right, just having an entrepreneurial mindset, right, that you're thinking about, oh, I have an idea to make this better, whatever it is, something, a process in your workplace, for example, and how do I make this better, right, is entrepreneurial thinking. So I think it is really important to weave that into the educational experience of our students. I think it's really a balance, though. I also think it's important that we sort of build a foundation for our students across many disciplines so that they're exercising all parts of their brain. They've done the math and the science and the philosophy and the studio art and all of those things. They've kind of exercised all those parts of their brain. So it's really important for institutions of higher education to build that foundation to enable people to go out and be nimble in their careers, but then also weave in this idea, the experience of entrepreneurship. So we, for example, launched a technology entrepreneurship class last year, but open to all students, not just engineers, because it's of benefit to many disciplines. I know there's some entrepreneurial activities at Dartmouth going on in the music department and the government department, right? Places where you might not think, why are they thinking about entrepreneurship? And so you're right, it touches on all of these disciplines. And so it's really about, during the educational experience, achieving that balance between knowledge building across disciplines and sort of skill building and philosophy building around things like entrepreneurship. So that's, I think, really critical. One other thing I wanted to mention is Eric Fossum, who you mentioned, is oversees our PhD innovation program also. So this is a very unique program. Usually you go to a university to get a PhD and when I was doing mine, there are no windows, I'm in a lab, and you just spend 5 years with your head down doing research and becoming an expert in the field. We have a program here that also allows entrepreneurially interested students to take business classes as well, entrepreneurship classes, so that while they've got their head down in research, they're also learning about how to be entrepreneurial. And hopefully they come out of that program, many of them do, and they launch companies immediately based on the research and the work that they did. So finding new ways to integrate entrepreneurship into the educational experience at all levels, I think, is critical.
I've had the privilege and the experience to sit as a judge, for lack of a better word, on one of your school's kind of fast pitch competitions. This may be part of that innovations program. And students put together either a real company or a virtual company. And so many of them actually, I think, went on to start these companies, and they would do some research, and they would have basically a slide deck. They'd have 15 minutes or so to do the pitch. And I and other judges would rate them. And it was a little bit about like American Idol. I felt a little bit like the Simon Cowell judge. Like I was a little bit, because I've been down this road, right?
That's
I was a little bit, I had to check myself. I remember I didn't sleep well the first night because I thought, have I just dashed the hopes and dreams of some young person? But there was a couple that kind of phoned it in, and I kind of called them out on that part. But it was exciting to see from a young person's standpoint who has not been down the road, their view of, we're going to get funding, we're going to do seed rounds. And there were two types of students: those that really had a passion for the tech that they wanted to promote. That I could dig, right? That I was like, okay, I'm into that. And then I saw there was others that were, their total goal was to build a company to the point where they could sell it in 3 years. And it was really more of an end justifies the means versus the journey. And I think that reflects modern society, right? That there are companies that are born to simply sell, right? And to do seed rounds and then, IPOs and then cash out and then buy an island somewhere. But I was really into the creativity of some of the ideas and the collaboration. I started my business on my own. It was just me and, my family supporting me. My wife worked so I could do this crazy thing. But it was just interesting to see how they had someone who kind of had more of a financial background and someone that knew coding and someone that knew mechanical engineering and someone that knew chemistry, all collaborating, in an educational world. But I think I saw some of the, I think I was involved with people who will start companies. And, I know I can at some point say I knew them when, right?
That's right. That's right.
I'm just hoping I gave them a good review then, because if they come up to be wildly successful and I said they sucked, that wouldn't be good for me.
Okay.
That's okay. Yeah, exactly. Yeah, even Colonel Sanders was turned down, and Thomas Edison was turned down many times, because that light bulb just didn't light up. With the changing landscape of job markets today, how do you plan to equip students with the skills that will make them competitive and adaptable in their future careers? Lots changed. People have changed. The students coming to us, employers, are different today. Our needs are different today. How does a university setting kind of synchronize the needs and the skills?
It's a great question. So much has changed, and we have to accept that a lot has changed in order to then realize how best to innovate in higher education to address those changes. Something you were just talking about, the entrepreneurship experience you had as a judge and telling people what was wrong with their idea, right? That actually builds a skill that we're trying to figure out how to build even more, and that's resiliency, right? That students today need to fail more. They're coming perhaps from a background, some of them certainly coming from hard backgrounds, some of them coming from backgrounds where, everybody on the soccer team got a trophy, right? Kind of feeling. And so it's teaching students that it's okay to fail and to be resilient is really important. So having more opportunities for things like the pitch competitions you were describing is really critical. But also really integrating those what's sometimes called soft skills. I don't necessarily love that term, but the learning how to communicate, learning how to work in teams, learning how to work in diverse teams especially, that is something we need to do more deliberately in the education we're delivering. Sometimes there's like an ethics course that the engineers have to take, but really that's not enough, right? It's about integrating ethics, integrating communication and teamwork skills into many, many classes. And so that's something that, we're working on at Dartmouth. We have more work to do, but to really prepare students for a life. And they need those additional skills at the college level, at the high school level as well, in order to succeed in life. So really making sure that we integrate that in.
Yeah, one good class might be how to communicate thoughts in more than 140 characters.
There you go. There you go. Although at the same time, sometimes I teach a class, freshman seminar class, even though I'm an engineer. It's a writing class on energy and sustainability. And I really challenge them. They like to write and write and write. So cutting down your words to be more succinct is also
I think, I see both sides of that. But we're not limited in social engagement to 140 characters. In the real world, we can convey no matter how long it takes to convey it.
That's right.
I know I'm getting old when I start any sentence with the phrase "kids these days." We have all become our fathers. We all eventually become our fathers. What, in your view, is the state of the current generation of students versus past generations? You talked earlier about, your father had a job for life. My father had one job his whole life. When I was born, he was working in this same job as when he retired, right? So that's one change. People are a little bit more transient in terms of their careers. What other changes are we seeing with the current generation?
Sure. So I'll name a few things. One, they're always moving fast, and I think that's good for our world. We need fast solutions, and so that's one. This new generation is more committed to work-life balance than any generation prior, I think. And so companies need to figure out how to accommodate for that, and that's a good thing. This generation, as we know, is more prone to anxiety as well. And so we need to think about how to address that. We can't just deny it. We need to figure out how to address that. They're also more equipped to use social media and tech in kind of unique ways. And so sort of those differences are things that, again, both higher education as well as companies need to figure out how to best support the newer generation and the needs that they have. One example around the work-life balance kind of is around sort of remote work, right? And providing more people with an ability some flexibility to do some of their work remotely if it can be done that way. And so we need to adjust to accommodate for that as well, to have a more inclusive workplace, right? Where people should be coming to work every day feeling good about being their true selves and contributing to the mission of the organization, and making that more of a priority to communicate that to their employees and to involve employees in that goal setting, in that trying to sort of be the best company that they can be. And that's a little different from prior generations. But I think that the more we do that, the more it's going to benefit everybody and really help push products forward, right? Help make sure that we're taking that human-centered approach, right? So that we're arriving at the solution perhaps quicker or a better solution than we otherwise would have by embracing some of those characteristics that the newest generation is exhibiting.
Once a student graduates with a degree, what advice would you give them to pursue a career within their chosen field?
So I think the first piece of advice is do something that makes you excited, that gets you out of bed every day, right? So if you've studied engineering and you love engineering, really make sure you're taking a job that aligns with that passion. Sometimes I find that students take the job with the highest salary and then they leave pretty quickly because they're not getting that alignment with that passion. Maybe they're not even getting the work-life balance that they need, right? And so one of the most fulfilling things I see happen is when you have somebody graduate with an engineering degree, they can get a really good salary and they go work for a nonprofit to use those technical skills to benefit a nonprofit that's benefiting society. So I always am so thrilled when I see our students really following those passions to the benefit of society. And so that's the strongest piece of advice that I would give. But the next piece is really to look at the culture of the particular organization that you're going into. And as you change jobs, it should always be a question, right? Am I a good fit? Does this company align with my values or not? And making sure that you're really exploring that through the job interview process and hopefully coming out the other end being a contributor to something you really believe in.
Yeah, it's interesting you say that. Our company hires, obviously skills are important, particularly in certain positions within our company. But we concentrate more on values and culture than we do skills. Certain skills we can teach. Skills can always be improved. Value and culture, yes, things can happen that can alter that later in life, but it's much more rare that one changes their values midstream. That by the time someone is in their 20s or 30s, a lot of that is fairly set. But for us, it's important that we work as a team, and I don't mean that in a Pollyannish kind of way. We really have to work as a team. We are really a collective group of people that all share the same goal to produce the best products we possibly can, best in class, et cetera, change the world in a positive way. We make products that are very green, and that's just part of our ethos. And even though we're in a tech world, we still are environmentally conscious. So we really want people on our team that kind of share that passion, not someone who's just a good coder or a good electrical engineer, or a good welder or whatever. Right. Yes, we expect that too, but that's kind of down here. The other stuff is probably more important to be successful at our company, to have a career as long as that person wants to stay on our bus for their journey. It's interesting. From your perspective, what careers in engineering, in the engineering world, are hot right now? What do you see? Where do you see the void that are just starving for staff, talented people?
Yeah, it's funny you use the word hot because I will point to climate change and global
There you go.
warming.
Good segue. Yes.
So I think really starting from where our society's greatest needs right now, and really mitigating climate change is one. Probably the second one I would point to is related to the healthcare field. And so, of course, both of those big, huge problems that society is facing they need technical solutions, right? Be it from, we have faculty working on batteries that work in cold climates because indigenous people can't burn diesel anymore, and they need solar panels and they need batteries that operate at those low temperatures. So you think you're solving a societal problem, but you need technologists, you need engineers involved in those solutions. Certainly on the healthcare side, I mean, an example of like a medical device, right? We'll have more and more medical devices, sensors and actuators, controllers in the body, right? More prosthetics and smart prosthetics, right? And all of these things to solve a problem that humanity is facing. You need the engineering and the technical piece. So I would point to those kind of more general problems as being ways for engineers to plug in. And what's great about that is you can do that as a mechanical engineer, as an electrical engineer, as an environmental engineer. You don't have to just be one kind of engineer to get engaged. There are various on-ramps, if you will, to get engaged, no matter what your training is actually in.
Yeah, you mentioned medical a couple of times. During the fast pitch competition, several of the students were working on medical devices, wearable sensors and things like that, that would provide cloud connectivity and feedback and all this other kind of stuff. Well, it's most parents' dream, I guess maybe financially nightmare, but generally in the higher term dream, to send their children to an Ivy League university. The fact is, college may not be for everyone. It is not for everyone, right? And no matter what college. And in your opinion, what other forms of alternate education are out there, such as trade schools or whatever? What's your view on trade schools? What's your view on every child going to college? Right. I'm not asking you who should and who shouldn't, because that's not the appropriate question. The appropriate question is, what mindset, who would benefit, who would be successful from going to a 4-year or longer university experience versus a 1 or 2 year trade school?
Sure. Yeah, it's a really important point, and I think something that is definitely in the future of our country to think more deliberately about that and put more plans in place to make sure that we're guiding people to the right post-high school educational experience that aligns with who they are and what their goals are. I have a good friend who lives in Switzerland, and was there visiting her this summer, and she was explaining to me a little bit in more depth about what they do over there to really guide people towards different high school experiences, even depending on their interests, depending on how well they do on an exam, for better or worse. So I do think that it's important that we do a better job in this country of providing people with different skills that match who they are, what they're interested in. Certainly, if you have somebody who is very interested in learning more across a lot of different disciplines, then an Ivy League institution, many of the quote unquote, top-ranked institutions are probably going to be a good fit, right? If they're very curious and they love learning, they want to learn and take all these different classes in different areas to exercise all parts of their brain. So build that foundation, that a 4-year institution makes a lot of sense. A trade school, a community college is often more focused on skill building. And sometimes that makes more sense for some students, right? It's more about building very specific skills so they can go right into an industry job and actually start working, usually sooner than you do when you go the 4-year college route. So I think it's really important for every parent to take a real kind of objective look at their kid. I have 2 of them. They're 2 very different children. And so we approached it very differently for the 2 of them. And I encourage parents to do the same and really explore what the options are, because I think a lot of parents don't know that there are this variety of options available for their children.
Yeah, excellent. My second to last question is, I own a manufacturing company within the electronic assembly space. Many of my listeners either own or are in management of companies or on engineering level in manufacturing companies. How can industry in general support universities? We are the benefactor of your work, clearly.
Sure.
How can industry support universities in general, Dartmouth specifically, in ways that provide maybe a long-term ROI
Sure.
for the manufacturing companies and a benefit for universities?
And I'm glad you mentioned this, and I'll put it in the context of a field that you know well, the semiconductor field, and the CHIPS Act, which is a $50 billion or so endeavor by the U.S. government to really bring more chip fabrication back to the U.S. and to really make sure that we have trained individuals, right, from the community college level through the PhD in the area of semiconductors and other related fields, right, having to do with the computer industry. So it's really important that as we do that, as we're thinking about making sure that our students have that foundational knowledge as well as the skill set, that we're talking to industry about that. And so getting industry more engaged and helping the colleges and the community colleges think about what is the curriculum we need to provide to best prepare our students is absolutely important. Recently, because of my interest and Dartmouth's interest through President Bilak in the CHIPS Act and playing an important role in that, we've had conversations. Just yesterday, I was talking to IBM about this, and we've had great conversations with Micron as well, right, about how we can think about changing our curriculum to really address these really critical needs too. So having those conversations is important. There's the other obvious piece, which is making sure that companies are connected to universities for internship and career fairs and job placement and all of that. Most universities have great career offices. And so connecting in and finding ways to connect to the students, either through that traditional career fair or other mechanisms. There may be speaking opportunities in classes like you've done, Mike. There may be other opportunities at networking events to participate in that. And just making sure that that connection is happening and the path for internships and jobs are made available. And it's generally really easy to make those connections through those career offices.
Yeah, absolutely. And my last question, Alexis, from your perspective, my last question always has to do with a crystal ball. So get out your crystal ball. Let's look into the future. From your perspective, where do you see the future of education?
Yeah, so education, higher education in particular, is changing quite a bit. I think a real number one issue in front of us is that we need to rethink what we teach and how we teach it, what we research and how we research it, right? Because we're sort of dual purpose there, teaching in the classroom and researching in the laboratory. As I was mentioning earlier, right, students are different than they were certainly 50 years ago. And we have diverse backgrounds in the classroom. We have students that are needing work-life balance, that are more prone to anxiety, that are curious and want to explore their own interests. And all of these things then need to influence the curriculum that we offer the students. And then people are coming in with different educational needs, right? Accessibility needs, just backgrounds, right? And so how do we meet those very specific educational needs? When you've got a class of 20 students, and they need different things. How do you meet those? And how might technology play a role in helping address those differentiated needs of the students? And that's not just at the college level, but certainly K-12 as well. So it's a lot of change that I foresee, that I'm not alone in that way. But I think that change is necessary and will lead to better information being extended to our students. This ability to detect, for example, fake news from real news is really critical. The ability to make informed decisions as an adult requires that imparting of real knowledge. And I think we're not doing the best job that we can. And so that change in the future to be more human-centered, to address those differentiated needs, to teach important topics that people need to learn today to be well-functioning, good citizens in the world, will only be of benefit to everybody if we can do that.
Wonderful. Well, Dr. Alexis Abramson, Dean of the Thayer School of Engineering at Dartmouth College, thank you so much for spending the last hour or so with me and my audience. I really appreciate it. I love the work your school does, your college does. The members of the staff that I know, a couple, I have a lot of respect for. I love traveling there annually and speaking to the students. Like I said, it fills my tank up, my optimism tank up every year. I'm very confident that our industry is benefiting from the work that your school and others are doing to prepare, the people who are going to carry the torch forward for generations to come. And I'm also keenly aware that it's not easy. When it's a moving target, people change, society changes, generations change, and even though we think that this generation is so unique, so were the generation of the 60s, so were the generation of the 40s, so were the generations before that. And it's kind of a rite of passage that we think that the new generation is so different, we worry, we get anxiety. Talk about young people having anxiety. I think old people get anxiety about the young people, right? So, but society survives. We flourish on that. And and I know that can't be easy to have to navigate those changes in addition to having to educate, right, on the basics of science, which tend not to change, right? So it's definitely a moving target, and I appreciate all the work that you do and your team and the educational institutions in general. So thanks for all the work you do. Thanks for sharing some of that work with me and my audience today, and I really appreciate your time. And I look forward to meeting you in person next time.
Absolutely.
Next time I'm having drinks with your students, you can come and join us.
That's right. Let me know.
You're invited.
All right. Thanks, Mike.
Thank you. Well, that's another episode. Thank you for listening to or watching the Reliability Matters podcast. Be sure to subscribe to the podcast on your favorite podcast app, or if you're watching this on YouTube, be sure and click the like, subscribe, and bell icons to be notified when new episodes are released. We release new episodes on the second and fourth Tuesday of every month. A special thanks to Circuit Assembly Magazine's PCB Chat at pcbchat.com and Ascendo Reliability at reliability.fm for syndicating the show. Thanks again for being part of our podcast family. Stay safe, stay healthy, stay happy, and perhaps most importantly, keep doing it right. I'll see you again in 2 weeks.
Thanks for listening to the Reliability Matters podcast. Join us on the second and fourth Tuesday of each month for new episodes of Reliability Matters.